Talk about how we prepare materials, how we get ready for I wanted to turn, does this, both of them? Got it, thanks. Anybody see anything wrong with this picture? Isn't that Sesame Street where it's, how does that go? Anything wrong with this? There's some kind of song? Never mind. Can you see the lumps in here in your book, in the page in your book? Can you see the buildup within this granulator, on the granulator walls? So how did I do? That normal stuff I hear all the time. Well, we have lumps in our powder, and the paddles on the tablet press break them up as they get into the machine. Is that a reasonable thing to think? Absolutely not. You know, the powder can actually caress and hold a lump, almost like you could take an egg and put it in the powder, and that egg wouldn't break up because the powder is actually protecting that egg or the lumps. And so a lot of times when you have an agglomerate, when you have something held together, it will not break up later on. All it will do is impede the flow, change the compression, have an impact on the output. So when you see stuff, what I'm trying to drive across here is a flag, and it's telling us how well we're doing. It's giving us a metric for our performance. This particular product was interesting. It's a very expensive product. It's a drug. The operator took the bag out of the drum and put it on top of the tablet press because that was the last to run. You could no longer scoop it or get it out of the bag. You had to do it by hand. So he set the bag on top of the press, and the bag's sitting there, and the machine's shaking a little bit, not quite that much, shaking a little bit like this, and the lumps start coming up out of the powder. It's not an unusual thing, but it's a product that they were making for 10 years. Really a non-optimized condition. What would you expect from it? What is it going to do for my product performance? Will it allow me to run 10,000 tablets a minute, or do I have a sacrifice? What's it going to do to me in the long run? So every time I see something like this, I'm trying to say it means something. When I have something built up on this bowl, in some companies would look at this granulator and say, that's successful. Because usually there's about 2 inches of buildup. And I don't have 2 inches of buildup today. I only have a little bit of buildup, so we're better today. But what that tells us is that there's an imbalance. There's a non-optimization. And that's what we're going to kind of try to pinpoint. So let's get a little bit of homework done. Raw materials, we talked about, they have different physical characteristics. Some are hard, some are tough, some are soft, some are plastic. They react differently to each other and to the environment and to the type of machine that they're on and the way that they come to you. That are they consistent is a driving factor for us. We hear all the time some statement, you might have heard this before. Let's try this out. It's always worked well before, but now it's not running good today, and nothing's changed. Anybody ever heard that? And nothing's changed. Don't raise your hand, because I don't want to know, and I don't want anybody else to know, but I've had it happen to me a million times, and I guarantee that something changed. What changed? Well, we don't know. Sometimes it's stuff that you don't know on the floor. You're following a procedure, you're following a batch record. You didn't always see that raw material or where that came from, how it was handled, where it was managed, what was done to it. You ever seen a bag of raw material that comes in and it's like a brick? And you have to use something called a Louisville slugger, a pre-breaker, to break up the powder so you can do something with it. Is it a wood bat or a metal bat? She's giving me a dirty look. I'm getting that quality control look. Okay, so the point's made that there are inconsistencies in raw materials that come in, how we order them, how we staff, how we look at them, identifying the problems. So let's take a look at what we're really after. That the press is the report card. The press is really delivering a lot of information to us. If it's not making a good tablet, it's not necessarily the press's fault. It could be. It could be that the press is set up wrong, the tooling's bad, or it could mean that there's a change in the powder that we're working with. So So we need to be able to differentiate between this machine, between the tooling, and between the powder and how the powder works. So we got a problem right now. Anybody knows what's wrong? Press is running backwards. You didn't see it here first. It's actually a Stokes press, sorry. No, I'm just kidding you. But the press is the report card. And to me, that press is telling us everything. Looking at the tablets, how they're coming off, what the weight control is, what the hardness is, how fast can I run it, how can I optimize it, what am I getting performance-wise off the machine, all equates to how well have I prepared these materials to go on the press, how well I've set up the press, how well I'm doing all the way around. But what happens to me a lot is when I go to a company, they'll say, Mike, the press, it's not working, and it's the press's fault. Well, and I know why they're saying that, because if the first thing out of my mouth would say that, well, maybe it's the formula, that wouldn't be a good thing, would it? Because nobody wants to change a formula, and they don't want to change the process. I had a guy that called up and said, hey, we've gone through validation, and now it's not working. Can you say that again? It was validated, but it's not working. So am I missing something there? So it can't be really well validated if it's, what's the statement? Once is luck.
And 3 times is validated.
Thank you for filling in the question. All right, so I'm going to move on. So we have to look at the process knowledge across the board. These are our 4 big variables. Materials, what happens to those materials, how they're stored, what's done to them, how old they are, all the information we can on the materials. Same for equipment. What kind of condition are we in? Great thing about being here is being able to look at that and compare. It's great to have multiple machines to compare to. Some of the things we'll look at is mills and how they work, and the difference in blades, and how one mill sitting right next to another one can produce a totally different product with everything being the same. I was in Puerto Rico a couple of years ago. I had a customer with 8 of the same exact tablet presses. One product they had would only run on one of those presses. It would only run on one. Why? You know, so there's why is the equipment, what was different between that machine and the other machines is what becomes important. What happens with the environment? If you're manufacturing in 2 different locations and a product's successful in one and not in another, and you're using a lot of the same things, is that the environmental issue? And what does my tech know? What does my operator know? What are his skills? Every company has one guy to go to. If it's not working, go get John. If it's not working, go get Lucky. Go get the guy that's going to make it work. And every company has that guy. And if that guy's off today, guess what? You have to wait. You either have to get help or figure it out. But a lot of companies have that mentality of waiting on that one particular person. So how successful was I? I took this powder, took my granulation, I added my pharmaceutical glue or my binder, I granulated it, I put it on the press. Well, I granulated it. Did I do good with the granules or bad with those granulation? Those big giant balls of granules, aren't those called agglomerates? I'm being a little smart right now, but that's a problem. That is, if this was my granulation, if I granulated and ended up with these balls of agglomerates, what do you think's inside of those? We don't know. 1 or 2 things. They're either a lot of moisture or it's just encased. So it could be dry inside or wet. If it's wet inside and I mill those up, I can distribute those wetted granules throughout my whole batch. And then I can have sticking uniformly throughout my whole batch. So controlling the process or building these granules is real important. I could end up with that defect. That is, if I don't process right, if I don't build the granule right, I can end up with a defect. And I can see it at other places. I can see it in my granulation bowl. I can see it on my tooling, that here I have a buildup of granulation on the punch tip, that waxy buildup. What does that mean? It means that I've got a buildup there that as I'm compressing, the punches are starting to get tight. The punches get tight, I have to clean more. I have to slow the press down to get good uniform tablet hardness. So anytime I see buildup on the tooling, it tells me something about how well or how poorly I manage the granulation. So what I'm encouraging you to do is to look at all the evidence you can whenever you get a chance to look at the tooling, the granulator, the blender, the mill, how they're doing. Look at the surfaces and try to relate what they're doing. And that's what I'm going to try to do as I go through this to make sure that this is identified so that it can have a result of sticking. So that's what we're going to do here in the next bit, and we'll talk about excipients, not just the API that we've talked about so far, but a lot of times we only have 2 ingredients in a tablet. One of them is the drug or the active ingredient, the API, the active pharmaceutical ingredient, or for the nutritional guys, your active ingredient, and the excipients. The excipients are everything else. So we either have the active or an excipient. And there are basically 13 categories of different types of excipients: binders, fillers, lubes, disintegrants, glidants, compression aids, colors, flavors, sweeteners, coatings. Each of these are excipients that we add to help the performance of the tablet or help it however we need to, color-wise, taste-wise, whatever we need to do. But those excipients can work for us or against us. As we go through the process, I'm going to talk about what we need to have. What's important with a tablet? Thickness, hardness, weight, friability, disintegration, dissolution are the key things that we're going to start with here. That each of these, and which one was the most important? Weight. Weight's the driving factor. What would you say the next most important was? What's next? Weight, then what?